Hi future scientists, I'm Atom. Let us explore the meaning of the slope of the VT graph and the area under a VT graph in relation to an object's motion. Slope of a VT graph and acceleration. Here is a VT graph showing Isaac's car trip. Slope of any segment equals rise divided by run, which equals change in velocity divided by time interval, which we can write as delta V over delta t. Since acceleration equals delta V over delta t, the slope of a velocity versus time graph tells us the acceleration of an object. Let us calculate Isaac's acceleration for each segment of the journey. The graph has 4 segments. Slope of first segment equals plus 60 km per hour divided by 2 hours, which equals plus 30 km per hour. So the acceleration equals plus 30 km per hour for the first segment of Isaac's journey. Slope of the second segment is equal to 0 since the line is horizontal. So the acceleration equals 0 km per hour because Isaac is traveling at a constant velocity. Slope of the third segment equals negative 40 km per hour minus 60 km per hour divided by 4 hours, which equals negative 25 km per hour. So acceleration equals negative 25 km per hour. Slope of the fourth segment equals 0 km per hour minus negative 40 km per hour divided by 2 hours. And that equals plus 20 km per hour. So acceleration is plus 20 km per hour. Area under a VT graph and displacement. In this position versus time graph, the velocities are constant plus 2 meters per second. Since velocity equals delta d divided by delta t, which equals positive 4 meters divided by 2 seconds, and that equals plus 2 meters per second. Here is its matching velocity versus time graph. Since velocity equals delta d over delta t equals velocity times delta t. So the area under the velocity versus time graph tells us the displacement, which is the object's change in position through a period of time. From the dt graph, we see that the displacement is plus 4 meters. In this VT graph, the area under the graph is equal to plus 2 meters per second times 2 seconds, and that equals plus 4 meters. So the displacement equals plus 4 meters. Let us find the total displacement for Isaac's car trip based on the VT graph. The displacement from time 0 hours to 2 hours is the area of the shaded triangle, which equals 1/2 times 2 hours times plus 60 km per hour, and that equals plus 60 kilometers. Delta d from time 2 hours to 4 hours is the area of the shaded rectangle. So that equals 2 hours times plus 60 km per hour, and that equals plus 120 kilometers. Delta d from time 4 hours to 6 hours is the area of the shaded triangle, and that equals 1/2 times 2 hours times plus 60 km per hour, and that equals plus 60 kilometers. Delta d from time 6 hours to 10 hours is the area of the shaded triangle, so that equals 1/2 times 4 hours times negative 40 km per hour, and that equals negative 80 kilometers. Finally, we sum up the areas to get the total displacement. So total delta d equals plus 60 kilometers plus 120 kilometers plus 60 kilometers plus negative 80 kilometers, and that equals plus 160 kilometers. There you have it. The slope of the VT graph represents acceleration, and the area under the VT graph represents displacement. Please subscribe, like, share, comment any questions for more science content. Happy learning. Thank you.